Hello my dear friend, welcome to the fourth use of dimensional equations, and that's to find the dimensions of constant in a physical equation. So if we have a physical equation or a formula, any kind of relationship we have, and if there is some constants whose dimension we don't know, then we can easily find out those dimensions. For example, let me give you the van der Waals equation, that is P plus A over V square times V minus B equals to RT. Alright, this is commonly known as van der Waals equations, and here let me tell you, P represents the pressure. You haven't learned it, but you're gonna learn soon. And V represents volume, R is universal gas constant, and T is temperature. A and B are constant. Alright, these are constants, so we have to find out the dimensions of these constant A and B. So whether you say by the principle of homogeneity or by simple analysis, you can say that this is pressure, so pressure can be added or subtracted with pressure only. Alright, and similarly volume, this is volume, so from volume we can only subtract volume. So from this we can say that A by V square must be pressure. From pressure you cannot subtract temperature, or in pressure you cannot add temperature or any other physical quantities. Pressure can be added in pressure itself, so A over V square is pressure. And similarly, from volume you cannot subtract temperature, or from volume you cannot subtract the pressure or anything. From volume you can only subtract volume, so that's why I can say this is volume. Alright, so we can say that A over V square equals to pressure. Right, this is pressure, this is also pressure. The principle of homogeneity says this, each term should have the same dimension. This term both should have the same dimension, so this is pressure. And let's put the dimensional formula of those all. Alright, so A, I don't know what is that, but I know this is volume, and volume has the dimension of L cube. Alright, and it's a square. Okay, and the pressure and the dimensional formula of pressure. Do you know dimensional formula of pressure? If you don't, then I'm gonna give you. Pressure is actually force applied on certain area. So force is mLT minus 2, and area is L square, so it will be M L. When this 2 will go up, it will be minus 1, so M L minus 1 T minus 2. Alright, so it's M L L minus 1 T minus 2. Okay, and further A is going to be now M, and now it is L minus 1. Alright, it's L minus 1, and this 3 times 2 6 will multiply this, so plus 6, and then T minus 2. Alright, so A we are going to get now M1 L5 T minus 2. So this is the dimension of A we find out. And similarly, if we talk about this term, a principle of homogeneity said that each term should have the same dimension. So dimension of V should be dimension of B. Alright, because from volume we can only subtract volume. Alright, so B is volume. I'm writing this side. Alright, so from here B equals to volume we can say. Alright, and B and the unit of volume is m0 L to the power 3 T0. Alright, because volume is length times breadth times height, and length, breadth, height, they all represents a dimension of length. Alright, so this is how we find out the constants dimension. These were two constant, we were not knowing what is their dimensions, and we did it just by using the very simple concept of a dimensional equation. Alright, I hope you understand this. If there is any more confusion or any doubt regarding this video or anything you need to ask me, then please feel free to comment below this video. I'll definitely get back to you, and please rate the video, like the video, and subscribe the channel. I will be really happy, and I feel a kind of inspiration when I see more and more number of subscribers.